Hi, good morning. Uh, I am a lecturer in mathematics from Giraj Government College, Nizambad, so Department of Mathematics. So today's topic BSc Mathematics third year, linear independent and linear dependent. So first linear dependent. So what is the linear dependent? So first given set of vectors v1, v2, so on vk. So these vectors linear combination we write c1 v1 plus c2 v2 plus so on plus ck vk. So equal to 0 bar. And here the scalars c1, c2, so on ck values are not all zeros, then we say that the vectors v1, v2, so on vk are linear dependent. So definition, let S equal to v1, v2, so on vk be set of vectors in vector space V, and c1 v1 plus c2 v2 plus so on plus ck vk equal to 0. If the equation has only trivial solution, means not all zeros, then S is called linear dependent. So linear independent. So S equal to v1, v2, so on vk be a set of vectors in vector space V, and c1 v1 plus c2 v2 plus so on plus ck vk equal to 0 bar. If the equation has only trivial solution means zero solution. So all scalar values are zeros, then that solution is called zero solution, and given vectors are called linear independent vectors. So if we check linear dependent or independent, then we write a linear combination of the vectors and equate to 0 bar. Next we find the using scalar values. So all scalar values are zeros, then given set of vectors are linear independent. In those scalars, any one is not equal to 0, then given set of vectors is linear dependent. So now one note, a set containing a single vector v is linear independent. So if v not equal to 0, singleton set is called linear independent. Second note, a set of two vectors is linear dependent if and only if one of the vector is a multiple of the other. If two vectors are given, so one vector is multiple of other, then those two vectors are called linear dependent. So any set containing 0 vector is linear dependent. So any set containing 0 vector is called linear dependent. If det in the determinant form, so if det S equal to 0, then S is called linear dependent, and det S is not equal to 0, then S is called linear independent. So once again, so non-zero vector containing singleton set is linear independent. So one vector is scalar multiple of another, then those vectors are linear dependent. Next, any set with zero vector containing zero vector is linear dependent. In the determinant form, that S equals 0, then S is called linear dependent, and that S not equals 0, then S is called linear independent. So here the problem, determine whether the following set of vectors in R3 is linear independent or linear dependent. So here we know in the determinant, so that S not equal 0, then S is linear independent. So or another definition, we find the solutions. So means first we write given vectors in linear combination form, and those linear combinations are equal to 0 bar. So C1 V1 plus C2 V2 plus C3 V3 equal to 0 bar. So we write V1 V2 V3 values here. We get the equations. So first one, C1 minus 2 C3 equals 0. 2 C1 plus C2 plus equal to 0. 3 C1 plus 2 C2 plus C3 equal to 0. So these equations we write in matrix form, and here A into x equal to 0 form. A matrix is 1 0 minus 2, 2 1 0, 3 2 1 0. So that matrix is reduced to upper triangular form. Again we write the equations. Those equations are solved for given variables. So the matrix A is reduced to upper triangular form, then here we get the matrix is 1 0 0 0 1 0 0 0 1. Upper triangular form means below diagonal elements are zeros. So into C1 C2 C3 equal to 0 0 0. So then here we get C1 into 1 into C1 equals 0, 1 into C2 equals 0. From first row 1 into C1 equals 0, second row 1 into C2 equals 0, third row 1 into C3 equal to 0. So here we get using all scalar values are zeros. So therefore given set we say that it is linear independent. Or another definition, if det value not equal 0, then we say that given set is linear independent. So here we find the det value, we get det value minus 1, it is not equal 0. So we say that S is linear independent. So next one definition, pivot column. So what is a pivot column? So what is pivot column means? So it is a non-zero column in the non-zero column. So is called a non-zero column is called pivot column. So one definition is there here. So if a matrix is in row echelon form, then the first non-zero entry of each row is called a pivot. So matrix is reduced to row echelon form or upper triangular form in that diagonal elements are not equal to 0. So diagonal elements are not equal to 0. Then those elements are called, those columns are pivot columns. So and the columns in which pivots appear called pivot columns. So here in the first example 1 2 minus 12 0 1 18 is there. So here what is the diagonal? So 1 1 is the diagonal. Below diagonal elements are zeros means, so diagonal values 1 and 2, first column and second column, first column second column are pivot columns. So in the second problem, so 1 1 minus 3 5, so diagonal elements are 1 1 1. So here diagonal elements are not equal 0. So 1 2 3 columns are called pivot columns. So in the next problem, so here first, third, fourth columns are called pivot columns. So means, so first column and second column. So second column is linear combination of the first column. So we say that second column is a free column or non-pivot column. So here next, so third, next fourth column, fifth column is linear combination of the fifth column is linear combination of the fourth column. So we say that are scalar multiple of fourth column or linear combination of fourth column. So fifth, sixth columns are free columns. These are not pivot columns. So in the next last example, 1 2 4 minus 3 1, so 0 0 1 6. Here first column is pivot column, second third columns are linear combination of first column. So we say that these two are free columns. So next fourth column is the pivot column, minus 3 1. So minus 3 1. So here next column is linear combination of the these two columns, first and fourth column. So last column is non-pivot column. So here in the problem, first fourth columns are pivot, remaining are free columns. So in Ax equals 0 equation, matrix A is reduced to upper triangular form. Then non-zero entries of each row is pivot column. Non-zero entries of each row is pivot column. So here one example is there. So row reduce the matrix A below to echelon form and locate the pivots. First matrix A is reduced to echelon form means upper triangular form using row operations only. So if the given matrix is reduced to upper triangular form, obtaining matrix is here 1 4 5 minus 9 minus 7, 0 2 4 minus 6 minus 6, 0 0 0 minus 5 0, 0 0 0, all last row is 0. So here what are the pivot columns or pivot elements? So first column, first element is pivot column. So next second column is pivot column. So third column is not pivot, free column. Next third, fourth column is pivot column. So here for third and fifth columns are non-pivot columns, non-pivot columns. So here pivot columns are first, second, fourth. First, second, fourth are pivot columns. Third and fifth columns are non-pivot columns. So here is there. So stars, square brackets are pivot columns. So the matrix in echelon form, and thus reveals the columns first, second, fourth of A are pivot columns. Remaining are non-pivot columns are free columns. So here next one note is there. So number of pivot columns are equal to the number of rows of a matrix. Then S is called the linear independent, otherwise S is called linear dependent. So number of pivot columns are equal to the number of rows of a matrix. Then S is called linear independent, otherwise S is called linear dependent. So method 2, matrix A is reduced to upper triangular form. How the given matrix is reduced to upper triangular form is, so here the method is, so given matrix is reduced to upper triangular form means first we want first row first element 1. We want first row first element 1. So by using that one we make below elements are zeros. By using that one we make below elements are zeros. So next we want second row second element 1. By using that one we make below elements are zeros. So this way we get the diagonal values are non-zero values and below values are zeros. Then that form is called upper triangular form or echelon form. So here next one note, if x1, x2, so on xk are linear independent, then it is not possible to write any these vectors as linear combination of the remaining vectors. So in the given set of vectors, any vector is linear combination of the another or others, then those vectors are called linear dependent. So no vector can be linear combination of the given set of vectors, then those vectors are linear independent. So here we see the one problem. So the problem, so which of the following vectors are linear independent or linear dependent? So first 1 0 0, 1 1 0, 1 1 1. So here these three vectors we write in the matrix form. So here consider the matrix whose columns are the given set of vectors 3 by 3 matrix is in echelon form, means below diagonal elements are zeros. So direct we say that here diagonal values are pivot values, pivot positions. So here we have 3 pivot columns and number of rows are 3. So we say that by invertible matrix theorem, so given set is linear independent, given set is linear independent. So number of pivot columns and number of rows are equal, then we say that given set of vectors is linear independent. So in the second problem, so first vector 1 1 0 0 0 0 0 1 1. So second vector is 0 vector. So direct we say that any set containing 0 vector is linear dependent. So the 0 vector is method number of the 0 vector is a member of the given set of vectors. So given vectors are linear dependent. Or another method, now consider the matrix whose columns are the given set of vectors. So and 3 by 3 matrix has only 2 pivot columns, first and last. So here 2 pivot columns, 3 rows are there. So both are not equal. So we say that given set of vectors is linear dependent. So one more example here. So 1 0 minus 3. Second vector 3 1 minus 14 minus 2 minus 1 1. So now here we write the matrix, that matrix reduced to upper triangular form. So number of pivot columns are equal to number of rows of matrix. Then given set of vectors are linear independent, otherwise linear dependent. So here consider the matrix whose columns are given set of vectors. The reduced echelon form of this matrix is, so here first, so reduced to upper triangular form or echelon form means first we want first row first element is 1. So here 1 is there. So by using that one we make below diagonal elements are zeros or below elements are zeros first. So here second row's first element 0 is there. So minus 3 is there, third row first element. So by using this one we make minus 3 0. So operation R3 equal to R3 plus 3 R1. So then we get the matrix 1 3 minus 2 0 1 minus 1. We change in third row elements with the operation R3 plus 3 R1. So we get the row 0 5 minus 5. So now next second row second element want 1. So 1 is there. By using that one we make below elements are zeros. So third row second element is 5 is there. So we make that 5 is 0. Means the operation R3 minus using second row here. So R3 minus 5 R2. So now obtaining the matrix 1 3 minus 2 0 1 minus 1. So here we get last row is 0. So now below diagonal elements are zeros. First below diagonal elements are zeros. So in the below diagonal elements are zeros, diagonal values, non-zero values are called pivot positions. So remaining are free values. So now first column, second column are pivot columns. Third column is free column. So here we have two pivot columns. So in a matrix 3 vectors are given, a number of rows are 3 3. So both are not equal. So given set vectors is called linear dependent. So here the next problem is the given matrix is 2 1 minus 7 2 3 5 1 2 minus 2 minus 3 5 1 2 4. So that matrix is reduced to the upper triangular form. So getting matrix is 1 0 0 0 1 0 0 0 1. So here we have three pivot positions and number of vectors are 3. So we say that given set is linear independent. So next one example. So x equal to 1 2 3, y equal to 3 2 1, z equal to 0 4 8. So is x1 x2 x3 linear dependent? So linear dependent means we check it is independent or dependent. So first given we write three vectors in matrix form, and that matrix A is reduced to upper triangular form, and in those upper triangular form pivot number of pivot columns are equal to number of rows of matrix. Then given set is called linear independent. So rows and pivot columns are not equal. Then we say that given set of vectors is linear dependent. So first matrix is reduced to upper triangular form. Then we get the upper triangular form is 1 3 0 0 minus 4 4. So last row elements 0 0 0. So here first column second columns are first diagonal values non-zero values are first column second column, third column diagonal are last value 0. So two values first second column diagonal values are not equal 0. These two elements are called pivot positions and these two columns are pivot columns. So how many pivot columns are there? 2. So this set equation has non-zero solution, therefore xyz is linear dependent. So next here polynomial linear independent dependent, we check given polynomials p of x, q of x, r of x. So p2 means second order polynomials. So we check these polynomials are dependent or independent. So first we write a linear combination of the polynomials equal to 0 bar. So linear combination is R into P of x plus S into Q of x plus T into R of x equal to 0 bar. So here R coefficients we write and S coefficients are. First we write constant values, next x coefficients, next x square coefficients. So here we get three equations: constant R plus 3s equals 0, x coefficients 3R plus S plus 2t equals 0, x square coefficients 2R plus 2S plus t equal to 0. So these three equations are we solved for R, S, T values. Or these equations we write in matrix form, Ax equal to 0 form, and matrix is reduced to upper triangular form. We get number of pivot columns and number of polynomials or rows of matrix A are equal. Then we say that given set of vectors are linear independent, otherwise linear dependent. So matrix A is reduced to upper triangular form. Here we obtain 1 0 0 3 0 minus 4 0 0 1. So means, so here it is which form? Here it is how many pivot columns are there? How many pivot columns are there means, so this 1 0 1 first column. So first column is one pivot column. So 3 0, here we get one row elements are zeros. So one row elements are zeros means, so that matrix det value 0. So we say that linear dependent. So linear dependent. So next one problem, x 1 2 3, y 3 2 9, z 5 2 minus 1. So we verify linear independent or not. So matrix A reduced to upper triangular form. So here in the upper triangular form we get three pivot columns. First, second, third columns are three pivot columns. It is in the upper triangular form, diagonal values not equal 0. Then we say that that matrix det value not equal to 0. Det value not equal 0 means, so the given set vectors form linear independent. Linear independent. Three pivot columns are there. Number of rows are 3. So one linear independent, we say that. By using determinant also we say that linear independent. And so linear combination linear combination elements in that scalar values are zeros. So this definition also linear independent. So next one problem, here 4 by 4 matrix is given. So this one also reduced to upper triangular form. So here we get three pivot columns. First, second, third columns are pivot columns. Fourth one is free column. So here 3. So here in the diagonal 1 1 minus 2 0 is there. So diagonal, in the diagonal any element is 0, then that matrix det value 0, then that matrix det value 0. So if det value 0, then we say that given set of vectors are linear dependent. Linear dependent. So direct we say that it is linear dependent. So next one theorem is there. So here the theorem is, so let v1 v2 so on vk be set of at least two zero vectors in a vector space V, then v1 v2 so on vk is linear dependent. So if and only if at least one of the vector is the set of can be expressed as linear combination of the others. So one vector is linear combination of the others, then we say that given set of vectors is linear dependent. It is if and only if theorem is there. So first, if v1 v2 so on vk is linear dependent, so then we show that in these vectors one vector is linear combination of the others. So we write linear combination c1 v1 plus c2 v2 so on plus ck vk equal to 0 bar. So suppose one vector not equal 0, that is vk is not equal to 0. Vk is not equal to 0 means its, so vector is not equal to 0 means, so its coefficient ck. So here ck value not equal 0. Ck value not equal to 0, then ck inverse exists. So this linear combination multiply with ck inverse and Ck inverse in the last Ck inverse into Ck, that value we get 1. So 1 into Vk, we write the equation, all values we write in the right side. So Vk equal to we getting the form minus Ck inverse into C1 V1 minus Ck inverse into C2 V2 so on. So last vector is Ck inverse into Ck minus 1 Vk minus 1. So here the vectors are V1 V2 so on Vk minus 1. Which one equal to Vk equal to? So we say that Vk is linear combination of the its preceding vectors V1 V2 so on Vk minus 1. When so given vectors are linear dependent, then one vector is the linear combination of the remaining vectors. So it is the theorem. So in the reverse also we prove one vector is linear combination of the remaining vectors, then we show that given set of vectors are linear dependent. So thank you very much.